In this example, we're going to discuss the domain and range of a composite function. So there's a very specific property about the domains and ranges of composite functions. And this reads as, if the domains of two functions are restricted, take note of that particular word restricted, meaning that it has some limits. Then the domain and range of the composition of two functions are also restricted. So take note of this property very, very carefully. And we're going to embed these properties into example number 2. Let g of x is equal to x minus 3. As you can see here, g of x is equal to x minus 3 for restricted domains from 2 to 7. Meaning this is your x values and the set of your domain from 2 to 7. And let f of x is equal to negative 2 plus 8 for x values ranging from 1 to 5. So our restricted domain is from 1 to 5. What is very important in restricting our domains is to find the pattern or the character of our graphs for those certain domains and be able to identify also the ranges of those specific domain restrictions. So the requirement for letter A is to find fg of 5, and later on we're going to show how we found this by sketching the graphs of both g of x and f of x for those specific domains. So having learned how to get the values of g of x from the previous discussions, we have g of 5, which we are going to evaluate from this equation, g of x. So our g of 5 is equal to 5 minus 3, which is just equal to 2. So our f of g of 5 then is equal to f g of 5 is just equal to f of 2, which is just equal to, substituting 2 to our x, will give us negative 4 plus 8, which will give us an f of x or f of 2, which is equal to the value of 4. Now let us get our graphs for f of x and g of x, which you can find in these illustrations. And I'm going to make this clearer by making an oral graphical interpretation of our g of x and f of x. So for the restricted domains of 2 to 7 for our g of x, notice this is our g of x, this is our g of x, and this is our f of x. Now if our x is equal to 2 for g of x, then our g of x is equal to negative 1. So let us highlight the point. If our x is equal to 3, then our x is equal to 0, or our g of x is equal to 0, which is somewhere here. If our x is equal to 4, then our g of x is equal to 1. So here. If our x is equal to 5, then our g of x is equal to 2, which could be found here. If our x is equal to 6, then our g of x is equal to 3. And finally, if our x is equal to 7, then our g of x is equal to 4. So let us have a linear, we have to connect all of the points. So connect it from here up to the last point down. Okay, so this is our g of x, the graph for g of x with restricted domains from 2 to 7. Now let's take a look at our f of x. For our f of x, if our x is equal to 1, then if our x is equal to 1, our f of x would be negative 2 times 1 plus 8. That would be 6. That's why we have here 1 and 6. If our x is equal to 2, then our f of x would be equal to 4. So if it's 2, it's 4. Now if it's 3, it would be 2. So it's 0. If it's 4, it would be 0, as could be found here. And if our x is equal to 5, then our f of x would be equal to negative 2. And connecting all of the dots, we get a graph which is, why do I always, they are not connecting. Okay, so from here up to here. Therefore, we have now graphical illustrations for f of x and g of x. Now, we're going to investigate whether our answers here, our answers for g of 5, which is equal to 2, and our f of g of 5, which is equal to 4, corresponds to what we get in our f of x and g of x. So our g of 5 here is equal to 2. So what is our g of 5? This is our g of x. So our g of 5 is here. And our g of 5 is equal to 2, which confirms what we have done here. And our f of x is equal to f of 2, which is still in the domain of f of x, because our domain is from 1 to 5. So we still have f of 2. And our f of 2 here would be here. So it's f of 2 is 1, 2, 3, 4. So f of 2 is equal to 4. 2, 4. So this confirms what we got in our computation for f g of 5. This is both algebraic and both algebraic and graphical presentation or computation of the value for our f of g of 5. So this confirms everything for letter A. Our requirement for letter B is to try to find fg of 8 and explain why this value is undefined. So going back to the basics, we have g of 8. Our g of 8 is equal to x minus 3, that's 8 minus 3. So that's equal to 5. Take note, it's 5. And our f of g of 8 is certainly f of g of 8. G of 8 is equal to f of 5. And f of 5 is just equal to negative 2 times 5 plus 8, which is equal to negative 10 plus 8, which is equal to negative 2. Okay, now our f of g of 8 is equal to negative 2. But why is this value undefined? Let's take a careful investigation about our domain restrictions for f of x and for g of x. Now our domain for g of x, our domain is x in between 2 and 7. And our domain for f of x is in between 1 and 5. In between, but including 1 and 5. And for domain g of x, it also includes 2 and 7. So look at our f of 5.